Before we can calculate differentials, we need to discuss what is meant by differential form. Suppose I have a function u is a function of x. I can take du dx, and I call this u prime. When I say put in differential form, what I mean is you take this du dx is equal to u prime, and you rewrite it as du is u prime dx, and it doesn't matter what the function is. It could be v, is v prime dx. If I have a function of x, all right, then df of x is f prime of x dx. This is a differential form. Now you're going to be tempted to say I'm just going to cross multiply by delta x. That's not mathematically correct. It looks like it, but it's not. So for differential formulas, if I multiply a function by a constant, the differential of that is a constant times du. I can add differentials. I have a similar product rule for differentials as I did functions, and the same thing for quotient rule. So let's do a little practice. If I have the function y is x squared and I ask for the derivative, you will put down y prime is 2x. You could also put down this is equal to dy dx, and you're going to see why I write it this way in a second. If I ask for the differential form, you put dy is 2x dx. Suppose I have the function y is 2 sine of x. dy dx is 2 cosine of x. But the differential of y is dy is 2 cosine x dx. Suppose I need to do the product rule here. If y is x cosine of x, then dy dx is minus x sine of x plus cosine of x. But the differential form is dy is equal to, now you're going to need parentheses or brackets or something, minus x sine x plus cosine x, and I'm out of room, so I'm going to put the dx down here. Suppose I want the derivative of y is 1 over x, then dy dx, I think you're getting the idea here, is minus 1 over x squared, while the differential form is minus dx over x squared. And finally, for the very last one, dy dx is minus 3, and the differential form Now sometimes we have composite functions. Suppose I have y as f of x is sine of 3x. Well, dy dx is 3 cosine 3x. So you do the same rules. So the differential form is equal to f prime of x dx. So this is 3 cosine 3x dx is equal to dy. Now what if I want the differential of a composite function? That's a little bit more work. You do the exact same thing. dy dx is equal to, it's going to do this. This is 1/2 times x squared plus 1 to the minus 1/2 times 2x. I'm going to simplify this as x divided by the square root of x squared plus 1. This is dy dx. You can also write this as y prime. But the differential form, dy, is x divided by the square root of x squared plus 1 dx. So let's go and put parentheses there.